here from our support team.
Hello, everyone.
He's, if you've ever called into our technical support here at CAP, I'm sure you've probably talked to Michael a couple times. I know we were supposed to have Gideon from Formlabs at this event, but he couldn't come for a couple reasons. But Michael's got a lot of experience with this printer. He's been printing parts on it over the past couple months, and I think he's a good technical expert to back me up on a couple of things. So let's get rolling. Before we start, actually, let me go over a couple of things. We're going to go over the basics of the printer, why it's different than others, some of the price, some of the features, the abilities, some of the technical details as well. Go over the cost and speed of the printer, and then we're going to go into an example of the workflow, like how you would print something. And in this particular webinar, we're going to do surgical guides. I know a lot of people here are really interested in doing models. I think we're probably going to have to do that one for our next webinar, but I think a lot of the sort of steps and the things that you need to know are pretty similar. You know, you're still taking something and you're still scanning it. You're still, doing a digital workflow and you're printing it. And so hopefully it'll be helpful. And I hope you guys find this all helpful. So let's start. I did a webinar, if anybody's seen it, it's probably about a year ago now, on a lot of the other print technologies on the market. The print technologies being like PolyJet, which is the jetted type printing, DLP, which is the projector-based printing, and even extrusion, just explaining those technologies. And if you're at all interested in 3D printing, I really recommend watching that video. It goes a lot into detail on that. For today, we're just going to talk about stereolithography, or called SLA. This printer is an SLA printer. And a lot of people sort of wonder about the technology and how old it was. It is actually something that was invented in 1986. It's one of the older print technologies. And it's actually pretty simple. It is pretty much, imagine a laser pointer and then a bunch of mirrors oscillating and bouncing off a couple of them and drawing a picture on the bottom of a plate. And DLP technology is actually a little bit different. It projects an image, and the best way to describe it is it's like drawing with a pen on a surface versus a stamp. So DLP is a stamp type print. This is a pen. And there's actually advantages and disadvantages of both. And I won't get too much into that, but there's some unique things about this printer that makes it pretty nice and really some advantages over DLP opposed to SLA. The printer is capable of doing 25, 50, and 100 micron layers, and actually depending on the indication type, the material, and a couple other factors, you have the ability to sort of pick from there. That's all done through the CAM software. You can set it. And for example, the surgical guide material, it is set. You only can do 50 micron layers because it's a medical device, quote unquote. So they have specific procedure and settings for that material, which is a good thing. A couple components, actually, while we're still looking at this this slide, if you actually look at the printer in front of us here, there's a couple things about it I'd like to point out. It has a resin tank, which is actually this orange bottom part right here. The wiper is actually a part of it. As it prints, the wiper moves across and cleans out the build plate area.
It also mixes it.
Yeah, it mixes it. It's temperature controlled, so it actually stays up to heat. So it won't actually, these resins operate at a very specific temperature. The build plate is this part up here, and in the video that's the part that's moving up. So it's screwed. And then for model materials,
right now I believe it's 2 liters.
2 liters, and if you move the parts around, because the silicone layer actually wears out in areas where you print. So if you move it around and you do smaller builds, maybe you could do
you'll start to notice clouding on the bottom of the resin tank over areas that you print more often. So you want to avoid those areas over time.
Yeah. So it's a consumable. And we can talk about, we're going to get into the sort of how much these parts each cost. The plate, how long have you been seeing the plates last, Mike?
This is still the first plate that we've been using. So
yeah,
use it for everything from model to the
surgical guides.
Surgical guide requires a separate plate.
Oh, completely.
Completely.
And that's like contamination issues?
Right, to prevent contamination and keep everything, I guess, contaminant-free.
Yeah. That makes sense. Yeah. The material is actually gravity fed out of a liter container, if you want to pull that out, Mike. And the material actually has an RFID in it. So when when you load it in, it knows what you're printing, which is pretty nice.
The resin tanks also have a chip that identifies what material was used.
Oh, interesting.
For that tank.
Good. I actually didn't know that.
It can be changed, but it does let you know.
Okay, so it will allow you to override that if you want.
Correct.
I see. Great. So let's put if you could put that back in. With some of those technical details out of the way, and we can go over any of this and sort of, I'm sure there's some questions involved. We're going to have a huge or a long part of this presentation is going to be questions and answers because I think there's a lot of sort of small stuff to all this. I'd just like to make one mention of sort of the timeline of dental mills in our industry and now 3D printing. If everybody remembers back 10, 15 years ago, there was really only a couple mill manufacturers. One of the big ones and the most famous was the Lava Form. I'm sure if anybody remembers though, them, it was a 3M system. It came with a milling machine, had this huge changer. It was thousands of pounds. Actually, people still use those machines today. Very, very high quality, very high accuracy. But the scanner, the whole system, the milling machine was $250,000, if not more. Bob Cohen actually, who started CAP, his laboratory upstairs started with one. And it did very well at the time, but it sort of evolved, as everybody knows. From there, we started to see in 2008 that mills came down in price. They were closer to the $100,000 range, maybe even a little bit less, and materials started to be standardized. So 98 millimeter started coming into shape, where lava was a very specific block. Everybody knows this. And then in 2015, actually earlier than that, I would say 2012, the Roland DWX50 came out. I think originally it was at $35,000 for that mill without cam, and it completely changed everything because it was a robust, reliable, easy-to-use milling machine that brought it to more than, instead of just the top 5% of labs in the country, every lab could afford one, or almost every lab. And that's even changing more today. They're getting more reliable and everything else. 3D printing is actually on a similar path. I'm sure everybody in here has heard of 3D. Is everything okay?
She says go to repeat at 3D systems because the sound cut out.
Oh, okay. Sound cut out. Oh, sorry, everybody. This is the problem with doing this stuff live. You sort of are owned by the technology. It's ironic, isn't it?
Yeah.
So 3D systems, their original printers were very, very expensive, very complex. Everybody sort of heard the stories, and I'm sure there's people in this webinar watching right now who even had experience firsthand with these things. In 2012, the printers started coming down in price, $60,000 roughly to $85,000. Even a year or two ago, really, for model production, it was an $85,000 printer or nothing. In our milling center, we had 3D systems. We have Stratasys now. Very good printers, large build plate, good production, high cost, high maintenance. Materials aren't even cheaper. I think the materials are even more in some of these cases. So, you know, as you can see by trend here, EnvisionTech came out with a wax printer. That was a little bit more affordable, and everybody remembers the Project 1200, which sort of never worked, kind of worked. And now today we have something that can be a contender for changing 3D printing. I truly believe it. It is the Formlabs Form 2. This is actually, the company is right down the road from us in Cambridge or Somerville, Massachusetts. This is their second generation printer. I think the first generation they learned a lot, especially in accuracy, consistency, and reliability, and they put all that know-how into this printer. And I'm sure if you've ever watched our other videos on what's going on, we visited their facility, young, energetic, smart group of people really driving these products and these printers. Everybody asked me, seems too good to be true. The printer at this price, the materials, the maintenance, the pieces and components. In a lot of ways, it's not. It's accurate and precise. It's consistent, and that should be on there. It's a simple user experience, similar to what the Roland did.
It's almost plug and play.
It is almost plug and play. Actually, while I'm thinking of it, this printer can be operated it needs to be set up with USB?
Either USB or Ethernet, and there's also Wi-Fi capability.
Yes. Once you have it set up, you can actually have it be wireless,
Yes.
which is really nice. So you can have it anywhere in your office, especially if you've got an environment where you're grinding PFMs or you've got dust in the air. Keep those separate. Although this is built to sustain dusty environments. They actually tested that, which is cool. Low cost, obviously. I think that's one of the really defining features of this printer. And the ROI makes sense. I mean, we have a printer that can do models that all of a sudden, if you're outsourcing models for, even if you get them at a low cost around $20, if you do them in-house on this little printer and it's under 10,
yeah.
I mean, that's pretty quick. I mean, I think you could be doing 10 models a month and all of a sudden justify something like this. Is everything okay?
Yeah.
You've got people whispering in your ear on that device. Like we've been talking about, one of the most exciting things about this printer is model printing. Over the past 4 to 5 months, Formlabs has been developing and working on the model material. And we actually have a sample model here.
Yep. So we are currently testing in-house.
Yep. It's pretty much there. I think there's the last couple tweaks, and there's also, they're getting the availability of the material up, and it's going to become more and more available, this specific material. And it feels and looks very, very good. The restorations look great on it, and as you can tell, opposed to the gray material that we were showing at Lab Day Chicago, it's much a better tone for working in dental.
Not to mention the option of removable dies.
Of course. So instead of just solid models, you can now have removable dies, which is very nice. And Formlabs, with the help of CAP, I can't say we did all of it or even most of it, but Formlabs took a lot of what we told them about accuracy of margin, accuracy of fit, across arch, everything that a Crown and Bridge lab is looking for in a 3D printing. And we gave them those specifications, and they actually, so they scanned a stone model, a control, on a D900L actually, which is a very accurate desktop 3D scanner, printed that same model, and did geomagic or convinced testing, which is pretty much, if anybody doesn't know, it's a heat map. So it compares the original or the control with the scanned printed model. And they found that you actually have two settings on the screen. There's a 50 micron print setting and then a 25 micron. And as you can see, the accuracy on the margin and even global accuracy is actually very good. I would, especially if you're doing a digital restoration where you're milling the margin off of a. This is going to be the magic of editing with YouTube. We could just cut these parts out. I'm sorry, everybody that's attending live. We're good. Get it fixed. Sorry, we're good.
Okay.
So it seems every 5 minutes or so we're losing audio.
Roughly.
Yeah. It is what it is, I guess. So I was talking about how Formlabs actually, I'm sorry, I just skipped the slide. Formlabs actually did a comparison with a large, very expensive 3D printer. We won't name names here, but the accuracy across arch and on die was actually very, very similar, which was not surprising, but it justified a lot of the accuracy studies that we saw. And everything okay?
Yeah.
Okay. So I sort of lost my train of thought there, but I think everybody gets the point. Accuracy has been vetted. It's a lot of the dial-in right now that we're seeing is on the 3-shape DME or the fit of the dies, but overall the material and everything, it feels and looks very, very good. Simple user experience, a lot of the things that we already talked about. So you can actually see the job on screen here. It gives you a little preview box. It gives you print time. You don't even have to be at your computer station. It's all on here in this little touch screen, which is very, very nice. The wiper, as we talked about, heat controlled.
It actually doesn't start until it actually gets to a certain temperature.
Oh, that's nice.
Yeah.
And it's auto feed, so I know there's a lot of other printers out there where you have to pour the material in, and if it runs out, it'll just sit there and wait for you. A full liter actually can do about 100 or so models. So it's actually a significant amount of material. Very easy, very quiet, and there's a range of applications that this printer can do. And if you could imagine, since the plate, once cleaned and scraped, can be used with almost any material other than surgical guides for sort of those specific recommendations, the tank and the plate can be pulled out almost in less than a couple minutes.
Yeah, it really just snaps in.
Then a new one can be put in, and you can switch into a more affordable matte gray material for orthodontic or diagnostic models. There's even other colors, white, black.
I think there's a lighter gray.
I have a customer who actually uses white for their diagnostic models because they like the way it looks so much. You know, whatever you want. So you switch the materials out. There's a host of diagnostic materials, which are pretty accurate and they look great. I just don't think they're as accurate as the model material, which is this beige material. There's these sort of peach color, pinkish surgical guide material, which I'm going to be getting into a little bit further ahead. And then coming out, there's a long-term clear material for night guards, splints, and I guess you could even use it for guides. But this is an exciting application because it's actually the first printed product that goes directly into the mouth, and that will have FDA on area new. I'm not even sure what the timeline on it is, but there's some printed dentures that are going to be possible on this printer as well. Something on that really quickly, not to get into too much detail, but the base is printed in a pink material, and then the teeth are printed on a separate white material, and I think they're going to have a couple of shades from what I've been hearing. But this is all very cutting edge. I think what we're going to do is we're going to do follow-up videos and maybe webinars on these new indication types as they come out. So what does this mean for a laboratory? And I think this is probably the most significant part of this webinar is, and I can get into some of the numbers on the next slide, but what this means is you can have a scalable manufacturing for almost any dental laboratory in our industry. The overhead is such, and actually I was told this story today by Gideon, where he had a laboratory customer and he just bought one on his own to do some testing to see if this thing could do anything, see where it fit in his lab with no direction at all. And he realized that he was able to do devices and products and all sorts of things because it was really a turnkey solution for him. He added 2 more printers. It went into his production, kept that third one there as prototyping. He then became a model material beta customer, added 2 more. And the scalability of this, I really think this is the direction the dental laboratories are going to go. Just like what the Roland did. Instead of having one large mill where if that thing went down or if it needed maintenance or anything like that, you were stuck. Yeah. Same with printing. When our 3D printers for models, we have 2 of them. We do a significant amount of models a day. With one of those are down, we then have to start paying overtime. Right. We've got to rush somebody in to do maintenance on these things. We're stuck.
Yeah. Half the production workflow is pretty much gone.
Yeah.
At that point.
So it is really half. So I think the ability to sort of plug and play these things, grow where you need to grow them, having even material-specific printers. So if you want to do your arches or your quads on 1 in 50 microns, for example, and you want to do your dies in 25 microns for the added accuracy, you sort of have the best of both worlds because you can print a bunch of little dies pretty quickly, where arches take a little bit longer, so you save a little bit of time on the 50 micron setting. So let's get into some numbers. This is sort of the exciting part, especially from a sales perspective. Feel free to take a screenshot of this. I think we should probably put this on the website too. It's really a lot of information on here, but it gives you some good numbers. So on the top, it gives you indication types. So the first one is quad with dies. The second one is full with dies. Surgical guides, quad and full. Splint retainer. So this is the new dental LT clear. And then it's giving me a warning, Robin. It's saying, would you like to hide all webcams? No, I'm just hitting no.
Yeah.
Sorry, everybody. And then finally, full arch, or out of the gray matte material, which is the sort of standard resin they call it. So the quad, 16 quad halves. Remember, so that's 8 full kits and dies. Not bad. This is something to keep in mind on this. This is the 15 micron layer thickness, and pretty much what we've been seeing is if you go to 25, it adds about 30 to 40% more print time. So as you can see, you can do just a couple quads in 3 hours of 50, or let's just say you're at the 25 micron on the whole build, maybe that's 4.5 to 5 hours. 16, this is a full packed build plate. 8.5 hours at 50. Let's just say maybe 11 hours at 25 microns, maybe a hair more.
Maybe. Sounds all right.
Maybe this is a good overnight build type thing. I'm thinking for workflows in production, you have maybe some smaller builds coming through the day, and then you do one big build at night. And then some cost. And I always take the cost with a grain of salt. I think it's probably a little more than $1.50 a quadrant. Let's just say even if it's 50% more, so let's just say it's like $2.50. Then an upper, lower, and die should be around $5 for a quad, and that's being conservative, which I like. I don't like to set expectations too low. And the same for the full arch. Let's just say instead of it's 3 to 5, let's just say it's 4.5 to 6.5. So you're going to get a full model kit, upper, lower, and die for about $10. At the lowest 8, maybe the highest 12, depending on the model, of course. All teeth, wisdom teeth, and all.
About the averages I'm hearing.
Yeah. So not too bad, especially if you look at okay, holding up. We lost audio.
Yep. It always comes back.
It comes back. Is it just Is it just audio?
Okay. Yeah, now it's back.
Okay. Is it okay? Sorry, everybody. We're back.
Hopefully.
So Mike got a message on his watch that actually the denture base and denture material should be available by fall.
Expected.
So we'll see. Let's just say fall or after. Because I'm sure a long-term denture has a couple technical hurdles, even with FDA and all that.
That's right.
But in any case, I'm not one to guess. So what are we talking about? Surgical guides. Some pretty basic numbers. You can see it can actually be pretty productive for guides. 18 guides in 6 hours. Again, the guides are set at 50 microns. That's all you can do. So this is actually really accurate to what you should expect. Splints. Again, it's not the fastest printer in the world, but it does a decent amount of production. The build plate is actually 5.7 inches by 5.7 inches. And then I believe it can print about 7 inches tall, roughly.
Excuse me, Owen.
That's okay. So actually a pretty big build plate. I don't know if you guys saw on that first slide, that was some examples of plates and everything else. It does quite a bit. Ortho or just diagnostic models, pretty similar in time of like a full build plate for models. So this is, again, we're going to go into the surgical guide workflow. We'll probably have another one of these, which includes model builders workflow and model specific. But I think a lot of these things are similar for other workflows, and hopefully it'll be useful to everybody. Everybody knows that you need to acquire the data. So either it's an impression scan off your desktop, a model scan off your desktop scanner, an intraoral scan. You need to get a surface scan. And for a surgical guide, you also need a CBTC scan typically, or a DICOM file. And then you need to take these files, and for a model workflow, you need to put it through Model Builder, clean up the mesh, mark the margin, make a die, all these sort of things. Or in a surgical guide, we're designing a surgical guide. We manufacture that part, and then we prepare and we clean. And I think there's going to be a lot of consistency. So this is not news to everybody. We've covered this a lot in our webinars. There's open scanners, open CAD softwares that will work. This printer is open. It'll work with any STL file that you can put into it. So as long as your manufacturing CAD software is producing an STL file, you should be good to go. It's usually what people need to worry about. And then I'm going to skip through this pretty quickly because I think this is, if you want to learn more about Implant Studio, we have other videos on YouTube. We have other webinars going specifically into it. So I'm going to skim through this. I apologize for being a little bit rushed on it. But again, here's a CBTC scanner. So we're doing the bone and the density and everything else, the surface scan, designing and printing. So let's start with scanning. Like I already talked about, this person needs an implant. And I'm not going to get too much into this, but you pretty much take the surface and the cone beam, Preform. It's actually completely free. You can download it today.
Directly off the website.
Yep, directly off the Formlabs website, totally free. So that means in your office, if you have 15 computers, you can have it on every single computer.
And through Ethernet, every single computer can actually connect to whatever printer is available on the network. So you are able to select and choose if you have more than one.
So that's really nice. There's software updates are included forever on it.
Yes. Firmware updates as well.
Yeah, firmware, that's really nice. The software is super intuitive to use. If anybody's used 3Shape, ExoCAD, Dental Wings, this is going to be like second nature to you. It's pretty much, there's two major differences between doing an organic shape like a surgical guide and a dental model. A dental model has the advantage of being flat on the bottom. So you can actually put it right to that build plate flat, or you can use this sprue connection if you want to raise it a little bit like the surgical guide that you're seeing on screen. Surgical guide, again, because it's organic, needs to have sprues. The way 3D printing works is if you have a surface in mid-space and all of a sudden it tries to print it and there's nothing holding it, it'll fall and then it crashes the build. This is why sprues are necessary in 3D printing, especially for this type of printing. But so for surgical guides, we typically orient at about 45 degrees, so we can stack them in. So we stack them in like this, the sprues go down, and we try to maximize the build plate as best as possible. So generating sprues are fully automatic in the software. It's actually really pretty nice, especially if you're dealing with the surface that's not critical to the restoration. And surgical guides, I always recommend the occlusal side, because obviously the soft tissue side, or the part where the is meeting with the guided part, you don't want that to have sprues. You don't want to have to finish it. It's easier to finish, as everybody knows, external surfaces opposed to caverns or internal surfaces. So it automatically places the sprues. The spruing is actually very easy. So on screen here, we're seeing you can drag the points, which controls where the sprues are. So in this video, it's actually showing it automatically sprued some in the guide hole. And this is true with doing a pattern for pressing and casting, a model, a long-term aligner, or whatever it may be. You can control where the sprues are, and you can minimize where they are.
It may are also the size.
So the connection size onto the restoration?
Size and density, so the amount of sprues that's actually added by the auto generator.
And it's pretty smart too. If you don't have enough, or if the sprues are running into each other or something like that, it turns red. It's got training wheels in a lot of ways.
In a lot of ways. There's some visual cues, especially for any areas that don't have enough support. There will be a red, I guess, tint to the on-screen model that shows that. You can also edit, changing the angle and anything, the sprue locations to help minimize or reduce those completely. There's a feature that lets you actually view everything layer by layer to make sure that all those layers have adequate support and that you don't have any failed prints.
Right. So, and actually, 3Shape and Formlabs are working together for a direct connection between 3Shape's output and Preform. So it'll automatically create and just place it into Preform for you. And I'm just starting to see these features come out. Looks really interesting. I think anything that saves labor or saves clicks is good to me. Excuse me. So this is validating the print. And actually, if you do download the software without having the printer, something that's really cool about it is, even if, say, you're just messing around, you nest some things, it'll tell you how long approximately you should take. And it also tells you how much material or what the cost of that material is.
It shows you how many layers it's going to be, depending on how
the micron thickness, right?
And the print time, there you hit the little refresh button, and it will actually give you a pretty accurate, actually, representation of how long the print will actually take.
Yeah, when it sends to the printer, too, it shows you right here how long the print's going to be as well.
Correct.
So if you have a station and it's in another room, again, you don't need to be next to the computer. You just view it right here. You check it out, and you're good to go. So it's all pretty simple, pretty straightforward. They've sort of eliminated a lot of the things on previous 3D printers that were a problem. Here's just a picture of it printing and pulling up here. So next is finishing and assembly. And so first, okay, we're good?
Okay, yeah.
All right. Sorry, everybody again. So finishing. Surgical guides specifically have a little bit of a unique workflow because you can tell the status of the printed product based on its color. Really interesting. It's sort of food for fact, even if you're not going to do surgical guides on this printer, it's just interesting. So it looks really clear printed. Post-cured, it looks a little more orange or peachish. Yep. Finished, obviously it just doesn't have sprues on it. Assembled, and then once it's sterilized, it's where it becomes very close to absolutely clear. Still has a slight tinge to it, but the nice thing about that is when you autoclave it, you know that it's ready to go in the mouth. So it's actually a good indication to the doctor, hey, this just came in from the lab. Yep. Let's autoclave it. Good to go. So I think that's kind of neat. This is the way it looks off the printer. Pretty simple to clean and start the post-processing. The build plate comes off, and actually you can see the person uses a handle. You pretty much scrape it off. Yep. It's actually got little lips on it, so you can get this tool. The tool comes with the printer. It comes with the full finishing kit. It pops right off, and when you're doing a full build, you sort of go through all of them. You put it onto a soft surface, and then it goes into a bath of alcohol. IPA, not beer. There's 2 baths. One is soaked, right, Mike? This is where your expertise really is. So yes. One is soaked, and then you put it into the second one. You let it sit.
Let it sit. So it's like basically a two-stage cleaning cycle. So you have your first batch, about 10 minutes. Afterwards, you put it into the second batch and let it soak for another 10 minutes before you actually cure it.
Okay.
Someone said freeze it before taking it off the plate actually helps too.
Yeah. So it's a little bit more. It snaps off a little more.
It comes off a little easier.
And in our milling center, we started using this printer for testing and products and all that. We actually put alcohol in a ultrasonic cleaner, and man, the thing, you just throw the parts in there. You don't have to take it out of anything. 5 minutes in there. They're as clean as can be. Even cleaner than even if you're really agitating it in the alcohol in this cleaning kit. So if you're doing any sort of production, highly recommend it. Just a couple. This is probably fine. All these parts come with the printer. This is in the finishing kit. Here's the UV cure light. It needs about 10 minutes in the UV cure light for all products. It actually shrinks just slightly, and it hardens. And an easy way to tell if it's UV cured for other materials other than the surgical guide is it goes from like a tacky, like you can actually, it's like sticky.
A little bit, just a bit of residue.
To something where it's not tacky at all. It feels like a finished product. It's not coming off in your fingers or anything like that. There's some specifics on the UV cure light. I think it's like 380 to 410 nanometers. We sell a printer that works very, very well. It works in about 10 minutes.
10 minutes.
So that's all great. The NextDent LC 3D Cure Box is the one that's on this slide. It's not the one that we necessarily sell, but if you're looking for the certified surgical guide workflow, I think the LC box is worth the money. The one that we sell is a little bit more affordable, and honestly, it's probably going to last a little longer because the LC.
So these weren't obviously sprued.
No, these are built flat.
Flat dies and everything.
Right, flat.
As far as sprues go, I mean, they're no real trick to cutting them. I think someone mentioned that it's easier to cut away from the actual object slightly instead of like really tight onto it. Yeah, so you don't want to actually place or get directly on to the object itself,
the surface.
And that has to do with some areas where there may be a little bit of a thin material that could actually break off as you're trimming the sprue. So you want to back it up a little bit, about halfway up the sprue, just to help avoid that.
Well, and I've noticed personally, because I've taken these parts and just snapped them off with my hands.
Yeah.
It'll make a divot. So it's important, and I think this kind of goes along with what you're saying.
Yes.
Leave a little bit on there, and maybe if it's a surgical guide, use that final polish or something to sort of gradually remove it, opposed to snapping it.
Snapping it off, yes, especially for any delicate areas.
Yes. So that's good. It's pretty straightforward. I mean, I'm sure laboratory technicians are very used to these things, and it's not too bad. They show a wheel here for polishing. Works well on the guides. I don't know if anybody's using a fingernail file in the dental lab. I don't know who put this slide together. I'm sorry, everybody. But a simple polish wheel. This also is like for dentures and so forth and so on. Yep. Acrylics, plastics. works just as well, just polishing it, giving it that nice final look and feel. And this is the doctor's side for sterilizing or autoclaving the final part. Comes to its final color, and you're good to go. Again, here's an overview of the workflow and everything else. This is my second to last slide here. So this is really an overview of all the products able to be printed actually right now. And something that's not on this list is castable pressables. So for patterns for casting PFMs or pressing Emacs, right now Formlabs is helping us with one of our beta testing labs to write up standard operating procedure for that product. I think we might do a webinar on just that one specifically because casting and pressing is pretty unique in that because it's a different workflow than anything else, much more analog in a way. But it's very specific on investment, post-processing, and everything has to be set. Just like, how you dialed in pressing when you first did it the first time. You have to make sure, you do it at the same time every time to consistent results. The same goes for this. So these three products on the left, so the diagnostic models, the model materials, very, very much close to being available. I think it's becoming more and more available. Yep. Surgical lab materials are definitely available, and these two are the future indication types. Again, the long-term splint material for direct use in the mouth, and then a printed denture. And I would say if they're doing a printed tooth, you could probably also print temporaries.
I've heard that asked before, so
I would assume so. I mean, if it's for a permanent denture for in somebody's mouth for more than a year, I'm sure, if there's 3 shades, A1, probably A2, B1 maybe of bleach, or B1, B more of the bleach, I'm sure you can use it for temps, which is pretty cool.
Yeah.
I like printing temps. It's I like my milling machines doing zirconias because it's where the value is in it. So any questions for me and Mike here about the Formlabs Form 2 printer?
I'll read them to you.
Okay, Robin's going to read them to us. I'm sorry again, everybody, for the technical difficulties. Hopefully it was bearable, and hopefully the audio quality and visuals have been clear. Let's see if I can pull some up too.
One more up there.
Oh, you're already on.
How do the printed casts compare to the EnvisionTech? What are the print capabilities?
For castable, I've had a couple labs and this is just, my honest opinion. I've had a couple labs have good success with the castable. It's actually a blue material. And then I've had some labs that did, like the investment wasn't right. And I think the problem is, EnvisionTech has been printing castable parts for a very long time. Even we had one for years. It was very consistent. And the thing is it had so much history, and everybody knew the right workflow, the right investment, the right way to vest and everything. I think we need to get that dialed in. I think the printers and the material are definitely capable of it. Maybe a tweak in the material, but the accuracy is there.
It's there. It's a very...
Oh, are we lost it again?
Yep.
Okay, sorry. Are we back?
Okay.
Are we back?
Yes, we're back.
We're back?
Yes.
Great. Okay. So what was I saying? EnvisionTech is they've been selling printers for a very long time, especially into dental. And I think it's just that the workflows are tuned and figured out. This will be figured out. They're going to make the standard operating procedure, what investment, what the cleaning procedure, the UV cure parts, and everything else. It'll get there. Like I said, there's a couple labs that are having success with it. There are a couple that aren't, and we're trying to figure out right now where that is. Okay, next.
Someone wants to know about the dental LT resin release date.
I don't think there's an official release date yet.
The near future. I think it's going to be sooner than later. I think it's definitely going to be before the denture material, which is set fall after. So I would say in the next 3 months, probably. I don't really know. I keep asking Formlabs, and it's like it's very vague.
Yeah.
But it's exciting. It's coming.
Do you have papers about this accuracy? Could you tell us which is?
Yes, we have Formlabs produced a white paper on the model material. It's accuracy. It's actually like 4 or 5 pages, really well put together. Is that on our website, Robin?
It should be.
It should be on our website. It's also on Formlabs' website for sure.
Yes.
It's on the same page that Matt Roberts did the video for Formlabs. I would check it out. Really nice, thorough, well put together. Definitely check it out. It's got some of those heat maps on it too, so you can see the comparison on the accuracy. Yeah, next.
When will the material be available for night guards?
That's the same. That's the long-term clear again.
Yeah.
It's coming. I'm sorry. I don't have specifics.
Hopefully we hear more soon.
Yeah, and we'll do, once it comes out, we're going to do a YouTube video, maybe what's going on with Bob, and we can look at it and see how the fit and the function is and everything else. Next.
Someone wrote, is that with or without supports? Oh, on print time, those print times you gave, is that with or without supports?
It does. It changes. So that print time, if you add supports, it's of course going to go up. But indicator within the software is fairly accurate as far as how long it will take based on the layers.
Well, I think they're talking about that one slide where it had all the print times.
Oh.
So I'm certain that the models, the print time is flat.
Yes.
The surgical guides, definitely with the sprues. There's no other way to do it.
I guess the splints would be as well.
Splints would be with sprues too. I'm 99% sure on that. So models flat, diagnostic models flat, anything organic like a night guard, surgical guide, sprues. Formlabs is developing a DME for 3Shape and probably a rule set for other model building softwares where the margin will be set to be within that parameter. And so with the right software settings, you really shouldn't run into that too much. And then for castable pressables, I would say on most preps, they'd be okay. Maybe some of those feather edges and veneers, that might be an issue. But I don't think that has anything to do with accuracy. I think that's more or less like feature size and capability is a way of putting it. All right, next.
How much time to clean up a model or split?
Oh, how much time to clean up a model or splint? Like you want to, so it's a couple steps, right?
Yeah, it's a couple of minutes. We have the 2-stage cleaning, of course, 10 minutes per bath, and then with the post curing, that's about another 10 minutes. So
20 to 30.
30 minutes with everything, and then of course depending on how many screws you have on your objects, and how time it takes to cut those off. And
our guest here asked about splints, so there would be sprues, and there would be some finishing on a wheel, to get that nice and smooth and finished. You don't want the patient having a divot or whatever on their other appliance. So, and again, the autoclave could really save a lot of labor and time. So with finishing, if somebody was really good, I would say 30 to 45 minutes.
That's all right.
A little bit less than this webinar.
What post-curing unit do you use and what brand?
We are selling the Rollins LQ light cure box. And it's an LED light source. There's also the LC cure box from NextDent. A little more expensive, but it's got a bigger internal size, so you can put more stuff into it. But the Rollins is about half the price, so that's the one we've been selling, and it's got a better light source anyway because it's LED. So,
can you print an accurate partial denture framework?
The person asked if we can print an accurate partial denture framework. Two things on that. Everything that I've heard is maybe. No, so minimum feature size again. I know the lattices and the clasps on partial dentures can get very thin and very small. That becomes a little bit of an issue. So maybe at the oversize those in design, there could be some workflow issues with that. And then the other thing is, I've heard that the material, when you sprue it and you're working on a very thin partial denture, it's very fragile. It's rigid. It can snap. It's hard to work with. I have a customer right now who's testing partial dentures for us. I think it's more or less, if you can get that printed pattern to be clean without sprues and not break it, it could work.
Good, but sprue, nesting would be tricky.
Yeah,
not at the right angle.
It's probably one of the trickiest indication types you can run into. But I would say maybe, and I would also say it might not be the castable pressable material because it's a little bit too fragile. I would almost guess like this is, for example, it's funny I have this in front of me. This is a durable material. and I've actually, this is like a little ball sample of it. This is very rigid, very hard. It holds its shape. I could imagine like a hybrid material between this and the castable material that could work very well for partials. So you could finish it a little bit easier and not break it.
Yeah.
But so let's just call that future indication for now. Thank you for the question. Next.
Does it shrink during the curing stage?
Yes, very, very slightly.
Does that post-cure unit from NextDent work for models?
Yes, it works for everything. We actually have one here. It works fine. Actually, I think the Rollins, the LQ one that we've been selling, the smaller one, is a little bit quicker because it's a little bit more intense, the light. But the LC works very well as well. Just it can do a little more volume, a little more expensive.
Is the post-curing time the same for all materials?
Yeah,
More or less.
more or less.
I've doubled up and put some like surgical guides in from
Or 20 minutes.
20 minutes.
Yeah.
To be safe.
Once it fully cures, it's not going to change from there. So you can put it in the sun. You can put it in the UV cure box for a little bit more. Is it audio less?
Yeah.
No.
Okay.
All right, we're back.
Yes.
Sorry, everybody. That's the last pause. I'm sure
Yeah,
we'll wrap
actually
this up in this
last
time. Sorry, everybody.
Okay, ready?
Did we get past that question? We're okay?
For the materials for, yeah.
Yeah.
For all. Can dies be printed without sprues?
Yes.
Yes, these are actually printed flat
Yes.
on the build plate. So
Yep.
it's actually recommended without sprues.
Yep. Yeah, it does well with just solid objects, flat at the bottom. Done. Next.
When would the stone color Formlabs material be available?
It's the person asks, when is the stone or the model material going to be available? It is available now. It's just in limited supply. I've been pushing on them to give us a couple dozen liters to sort of get them out to customers. Keep your TSR or your Zon telesalesperson in the loop and just keep asking. It's going to become available over the next couple weeks more and more. It's like a Nintendo product release. It's like they give you 2 and then they give you 5 and
Slowly.
That's probably not a good analogy. I'm sorry. Next question.
Can you print models with implants analogs? Have you done?
Yeah, sure.
Yes.
So the DIMs or digital implant models are pretty straightforward, actually.
It's the same concept as the removals.
Yeah.
The settings are still being dialed in and tested, but it can be printed, yes.
Yeah, so it's really just making sure it's a nice firm fit, just like a die would be. And then it's keyed, so you have a specific orientation and everything else. I don't think it should be a problem at all. I think it actually is less technical than printing a die, because the nice thing about digital implant models is the parts are consistent.
Yeah.
Where this is dies, as everybody knows, is a one-off product. Okay, next question.
What software do you need to make the removable dies models?
The question was, what software do you need to print or to make models, pretty much? There's a couple softwares.
We use 3Shape here.
Yeah, we use 3Shape Model Builder. I know Exocad has a model builder that's very good.
Yep.
Dental Wings has a model builder, and also Ceric InLab, I think.
I believe they do.
I think Ceric InLab has. I'm not a Ceric expert. I don't claim to be one. You might want to check on that, but I'm pretty sure you can output STLs out of Ceric InLab and print models from there too. The only thing I would say is all those products will have different, again, we run into the same question, but the different settings for the internal space from where the die and the model meet. So to make that as firm and sort of click into place as possible, it might need to be dialed in a little bit. Hopefully we could get like the sort of basic requirements for all these model softwares out to our customers. Very, very simple. Better to put this or remove the supports before light curing.
It depends. I've done both. I mean, it depends on how much space you have, how many units you have. It does make cutting screws a little bit easier. It's a little less delicate. But it really doesn't matter.
I don't like really handling the models when they're not like UV cured.
Yeah.
They're sticky. I feel like I'm sort of messing it up a little bit.
Gloves always recommended before you're handling.
Like it's almost like it's squishy. Like it's a little bit like.
It's a bit soft.
It's soft. That's a better way. That's a better word. So I say leave the sprues on, throw in the UV cure box, and do it afterwards. That's my recommendation. But
Either way will work just fine.
either way is fine.
What model material settings do we choose in the 3-shape order form?
That's a good question. So the question was, what model material settings do you select in the 3-shape order form?
So at the moment, there's no official release for that. We are working on a DME with Formlabs,
We have a
which
beta.
I've been testing.
We have a beta right now.
At the moment, everyone's just choosing the default model material and have been getting relatively good prints out of it.
Even Stratasys.
Even the Stratasys ones.
It's in the neighborhood.
It's just that even with those, it's just removable dies are really still not finalized. So any setting with solid models is fine. And
Okay.
sorry.
Robert is distracting us with elaborate signs that we have to read.
So hopefully the DME will be diving soon, and we'll get that out.
Yeah, so we have a beta DME. It's coming. I think we'll have it in the next week or two. And that when I put it in this video, that means that they have to. Hopefully, Formlabs is going to watch and listen and R&D and everything like that, and they'll have to get it done. All right, great. Thank you so much. Next question.
If you are printing overnight, do you ever have problems with it freezing in the middle of the process? If so, can you start it back up the next day where it stopped?
Mostly no, because if it freezes for any reason, it's usually an error. For any number of reasons, either the plate didn't lift off during the build, peeling, communication got cut off normally. Things like that happen, but it's not resumable. I've run into this issue before, unfortunately, but it's not very often.
It doesn't happen much.
No.
We printed something silly. I mean, this printer can print anything, so you can go to like Thingiverse and what are those other websites?
Thingiverse. There's a few other
3D
ones.
Warehouse. There's a couple.
Yeah.
There's a couple websites where you can get like things you can print for fun,
So-
Christmas presents, so forth and so on. We printed something huge, like the whole build plate, and it was like 18 hours or something like that.
Something rough.
And it did the whole thing. It was running for like 20 hours straight.
Without any issues.
Without any issues. I was like,
the weekends
without
any issues.
When I saw that thing go on the printer, I was like, this is it. This is for sure gonna, this is too much, too big, too long. But it did totally fine. So, knock on wood. So I think there's going to be some, every once in a while, probably 1% or less of the time, there'll be an error or something like that. But I wouldn't expect it.
So just be careful what you're printing.
Yeah, I think, especially with sprueing, and looking at the parts in the software.
Especially large flat surfaces that aren't screwed up can be an issue because it will cause the plate to get stuck to the resin tank. Basically, there's a suction that gets created, so it's not able to lift off, and that was the issue we ran into. But
also, replacing the build plate, it's similar to like a milling machine, right? You know what things to look for in the CAM software. You know when the tools are wearing out, and you can sort of start predicting these things once you own a mill for a couple months. And it's similar with the printer. When you're in the software, look for sort of the things that can maybe cause issues. And for build plates, they have a life. There's only a certain amount of things you can print. Oh, actually, that was a question I didn't answer earlier. The build plate is $59. So let's just say you can get a couple liters of material out of one build plate. So $59 for.
I think most materials is about.
Yeah, and I think for quad models you can do over 100. So for 1 liter of material. So let's just say you're doing 2. That's 200 models. So that means you need to add about 25 cents per model for the build plate. Sorry, I sort of went on a tangent.
Well, we tested with solid models. So if you're doing hollow, that could probably change the numbers a bit as well.
For the build plate.
For the build.
I'm sorry, the tank. The silicon layer is what wears out on it. What time is it?
Okay,
just over.
Oh, we're over.
Yeah.
Okay, we're over a little bit here on time, but let's do a couple more and we'll wrap this thing up. I'm sorry about the delay, the audio delays again, everybody. And I swear I haven't been giving any useful information in between.
Okay.
Let's see.
Are you going to integrate your materials into the 3-sheet library for available materials to use?
Yes. That was an easy one. Yeah, it's just, it'll be released very soon.
In regards to surgical guides, would you recommend inserting sleeves before curing as the guides shrink?
That's a good question.
That's a good question. Because maybe if you put the sleeve in, it's a little bit easier. Then let it cure around it. Then you have a more sort of
Snug fit. We have to test that.
That's a test. That's an interesting one. I don't know.
What is the cure time for the gray resin in the LQ box because it resets every 9 minutes, 50 seconds? Is there a better way?
For the gray resin, I just run it twice if you're really concerned. I mean, that box does have presets. And for most materials, I just run it twice at the 9 minutes and 50 seconds.
Yeah, 20 minutes then. 2 cycles.
Yeah.
And I've seen people getting away with 1 cycle pretty
I've done 1. I've done 2. I mean, it's pretty... I don't think the second one's really necessary, but if you feel safer that way.
It might also depend on the thickness of the material, like if it's hollow or not, because it is UV. It is penetrating through the material, so...
If you have a need to flip it for any reason, the object.
Yeah. So that's actually a good idea. So maybe if you're really concerned, do 10 minutes one way, flip everything upside down, do another 10 minutes. You'll be good to go from there for sure.
If I print models, is it accurate enough that I can use that model to wax up crowns for casting?
So as you can see on the previous model or the accuracy study, it's accurate plus or minus the 30 microns. And it's pretty consistent in that, and that 30 microns is the worst it gets. And I know clinically we always want to be a margin to be no more than 20 microns open. Otherwise, the doctor can get his tool in, he can feel a margin open, and then he'll reject the crown. So, yeah, I think it would be, I think it'd be all right. Again, I think it's probably better through digital workflows like zirconia and so forth and so on. But it would work. I mean,
one of our viewers chimed in saying they've done veneers on stone models, and
oh, you mean the printed model?
What's a stone model? And it transferred over with a 50 micron offset to the Form 2 model. So there's a 50 micron difference. Is what it sounds like.
Well, and you got to remember, in dental, for laboratories, we're always dealing with compounded inaccuracies, right? So and this goes for analog too. So the prep is done, the impression is taken, the impression material has expansion and has a sort of variability to it as well. It's not a solid thing. Then we will scan, trust the margin that you mark and you produce from that product, trust the milled or the printed crown, and use the model for, if something's wide open, that's a problem, right? That's when you catch it, check it out, remake it. Or you just use it for contacts and occlusion. But I think you could get some pretty good results by waxing to
like some people already have. So
yeah, 15 microns, like our anonymous viewer just mentioned, it's pretty good. I mean, I think that's clinically acceptable. I don't think you'll get washed. I don't think the doctor's surveyor will feel it. I think you're good.
How often do you change the build plate?
Depending on material. So surgical guides, they say every liter.
No, build plate.
Oh, build plate. I'm sorry. I get the tank and the build plate mixed up all the time.
You have to change it in all these months of using.
Yeah, we've never changed ours, and we've done probably 10 liters.
Roughly, or maybe more.
So can you take it off? Yeah. So the build plate is this is plastic, but the bottom, the actual plate is a metal. And I don't know if you can see this or not, but I don't know if you can see it or not, but we scrape and gouge and clean this plate.
Yep.
And I think if you're careful, actually, we've got some pretty decent gouging on here.
Yeah, that's from just scraping off the objects.
Yeah, I think you use your best judgment on it, and I would imagine you could get 10.
You probably won't even need to change it unless it's really compromised.
Yeah, and things, if it's really bad, things will stop sticking to it. So what I mean by that is when it first does its build, it's doing that first layer underneath the build plate. It needs to stick to this surface so it can pull up, and then do the next one and so forth and so on.
Just wipe it clean.
Wipe it
alcohol,
clean.
Let it dry.
And it's one of those things, stay ahead of it. So right when you're done, clean it.
Clean it, definitely.
Don't let it sit overnight. Just
You don't want it to cure on today.
Yeah, you don't want it to cure. That's good point, Mike.
I have some people asking if it's possible for us to print samples to check the accuracy.
Sure. Yeah. The only thing I would recommend for accuracy samples is if it's for a model with a removable die, we give you the DME or some requirements for the die settings, so you get the best result possible. Solid models, no problem. Those are easy because there's no interchangeable part. Just send the files over. Actually, we should make a Dropbox or something for samples. The answer is yes, but with DME.
Yes.
Or use a default DME and judge it on the accuracy of the die contact. Questions?
What model material, okay, yeah, do you pick for the dental model? Preform 2.11 doesn't give me the option to pick dental model.
It's not available yet. It's still in beta.
The software.
The software, yeah. So when you're starting a nesting job, you're first asked to select what material you're using. And at the moment, without the beta, the model material is not available.
I think it should be soon, though.
It should be soon.
I'm going to push them.
I'm hearing April. May.
I want to get it out to everybody. And I know the material is, a little hard to come by right now, but it's going to become more and more. So
I think it's open for pre-orders on your website now.
Or through your Zon telesales rep,
which 6 weeks, that's what they're saying.
Would help us out a lot if you could order it through that way instead of the website.
And how often do you change the IPA bath?
Good question, Mike.
Personally, about every liter.
Really? Both of them?
The first bath I don't change as often as the second one. It's just like
the rinse one?
Just the rinse one. It depends because you'll start to see a cloud of material start to actually form in the bottom of the tank, and it gets progressively darker.
But a liter of material could print like 100 quads. What?
Hold on.
Wait. Oh.
Okay.
All right, we're back.
So I think
Sorry.
the last thing was...
I feel like the delay is getting longer.
I know. I think the last thing you heard was...
It's cloudy in the alcohol
material.
bath.
The first bath, as long as it's just removing enough material, you won't see the second bath actually start to cloud as much
yeah.
or as quickly. I've heard people just not changing it at all, as long as it's not clouding the second bath as much. If that starts to happen, you want to just switch it out.
As long as the parts are clean.
Yeah, more or less. You don't want that residue on there when you're curing.
No.
Because it becomes sticky at that point.
Well, and I'm sure if you leave material on there and it cures, it's going to be a thickness or a layer on there.
Yeah.
So if it is a liter of material for both things of alcohol, I know we buy it in a gallon.
We buy it in a gallon, I think.
Which is pretty cheap, right?
Yeah, it's not that bad. But
$10? $10 a gallon. It's not too bad.
Yeah, I do maybe like.
So, but a liter is like 100 quad models. That's pretty good. Yeah, that's not too bad. Just keep an eye on it. And if you use an ultrasonic, since it's one bath, it might consume it more, but it's less volume of alcohol. I know the one we use is like a little tank like this. We just drop it in.
Right, and I mean, depending on your objects, you don't really need all that much alcohol per bath. I feel it maybe about halfway.
Oh, okay, so not fully, yeah.
So 1 gallon will do more. It's more than enough for both baths.
Good. I think we're that's all. So we're gonna have more content coming for this printer about the model builder workflows and post-processing that, long-term splints and night guards, which is very exciting in the near future, dentures down the road, and we're really happy everybody came and attended. Thank you very much. My name is Sam Wainwright.
I'm Michael. Thank you, everyone.
Yeah, thank you for stopping by.